All right, last question of this related rates series. So we have a conical tank. That means it's in the shape of a cone, and it's oriented like this. And it's being filled, so water's being dumped into it at a rate of 4 pi feet cubed per minute. They tell me a bunch of stuff here, and I've sort of indicated some of it here, but I'll sort through it. The diameter of the tank is 10 feet, so that's this full length right here. The height of the tank itself is 20 feet. They want to know how fast is the water level rising. That would be the height of this blue water here when the height of the water is 10 feet. So I tried to draw it here where this height is about half, because 10 feet is half of the 20-foot height of the tank. They tell me to give units. They give me the volume of a cone. So let's identify what we know to start. My height of the water is equal to 10 feet. I'm just going to write 10. My dV over dt of the water is equal to 4 pi. And I want to find the dH over dt. That's what I'm looking for. I know the height of the cone is, I'm not going to write it here, but the height of the tank itself is 20, and the diameter is 10. That also means that the radius of the cone itself is equal to 5. So let's get started with this solution. All right, so V equals 1/3 pi r squared times the height. Again, that's given to us. I'm writing it here. Let me explain the problem with this one. We have a height, a height and a dV dt, and we're looking for a dH dt. Notice I got volume, I got h, but I have this extra variable here. We do not want to try to take the derivative of this line with r's in here. We want to get rid of the r before we take the derivative of this line. And that's because otherwise, what operation is happening right here in between the r and the h? It's multiplication. You would have to use product rule on this, and you will wind up getting a dr dt, and we don't even know anything about dr dt. So we would like to reduce this equation down to just volume and h's so that it's a lot easier to work with the information that we're given. All right, so given that, I'm going to build out some, I'm going to get rid of the r. Notice for the cone itself, for the tank, what I want to do, the radius divided by the height. What is the radius of the cone? It's 5. What's the height of the cone, of the tank? It's 20. So what I can do is write r over h equals 5 over 20. Notice that simplifies down to 1/4. From there, I get r over h is equal to 1/4. You may be like, why are you doing this? Well, notice I've got an equation now that has r and h in it, and it's a pretty simple equation. What I'm going to do is solve for r, and it'll just have h's and numbers on the right side, and then I can replace that r with it, and then I'll only have h's in this equation here. So as I do that, I get r equals, I'm going to multiply by the h on both sides. I get h over 4. And then I'm going to combine this line with that line. So that gives me v equals 1/3 pi open close squared times h. What goes in the parentheses? Well, the h over 4 that we just solved for. So what's that give me? All right, so that gives me 1/3 pi times h squared over 16, because I got to square both the things in the parentheses, times another h. And then I'm going to simplify that to 1/3 times 1/16 times pi times how many h's are being multiplied? 3. So from here, I'm going to go ahead and derive both sides with respect to time. You may say, why did you leave these two? Why'd you leave these two like that? Well, you'll see as we go forward. The 3 is going to cancel with that when I do my power rule. So what do I get? I get, when I d over dt it, remember I've got v on this left side. I've got the derivative of volume with respect to time is equal to 1/3 times 1 over 16 times pi, all of those are coefficients, so they come along, times 3h squared. That's power rule times dh over dt. From there, this cancels with that, and I get dv over dt equals 1 over 16 times pi times h squared times dh over dt. And so, from here, I just have to sub in the things that I know. I know dv over dt is 4 pi, so that's going to go in right here. And I know h is 10, so that's going to go in right here. And then I'm going to solve for the dh dt. So what do I get? 4 pi equals 1 over 16 times pi times 10 squared is 100 times dh over dt. So from here, pi's definitely cancel on both sides. I'm just going to multiply by 16, so I'm going to get 4 times 16, and then I'm going to divide by my 100, and that's equal to dh over dt. Why did I do that? Because, again, it helps to be able to look forward a little bit. I have a 4 and a 100. I can do 4 divided by 100 and simplify that pretty easily. If you had to use a calculator to get this, I feel like it'd be pretty reasonable, but I'm trying to show how it can be done without one. So 4 over 16 is the same as, 4 over 100 is the same as 1 over 25. Times the 16 is equal to dh over dt. So I'm going to write that as dh over dt equals 16 over 25. And what are my units? Well, it's the height. So it's going to be feet per, what's my time unit? Minute. Comments, as always here. These are on the more tricky side for related rates problems because people tend to struggle with this. Or they take this derivative incorrectly. What I want you to see is that when we're doing this, we really just want to get it down so that we have one variable. Having 3 variables in this related rates problem, no matter how you think about it, is going to be an issue. So we want to get rid of the one that we don't care about, which in this case, we care about h and v, so we want to get rid of r. We do it this method by just looking at the shape and doing some division. Sub it in, do your algebra correctly, take your derivative, sub all your stuff in, and then you can solve for the thing that you're looking for. And we get dh dt is 16 over 25 feet per minute. Thanks, y'all. Peace.